Hi and welcome to the first episode of our Advanced C++ tutorial series, where we will showcase some niche Unreal Engine programming topics. Today we'll take a look at communication via TCP socket. I have already prepared a basic third-person camera project with the widget and an empty actor that will soon serve as our TCP controller. As you can see, widget has two main parts: text input, where we'll write our IP, and a connection button that is quite, I think, self-explanatory. We are playing in the dedicated server mode, and we'll create a communication from the server to the client without RPC, just pure TCP. In this demo project, we can move, jump, and open our widget with E button. As you can see, we can write our IP here, but when we click connect, nothing happens. But that will change soon as we write our TCP server. Before we begin, we have to add two dependencies inside build.cs: networking and sockets. First one will give us access to the network subsystem. Later gonna allow us to use networking sockets. Now let's declare everything we will need. fsocket pointer, that is a virtual struct that will allow us to manage connection between client and the server. It doesn't do anything by itself, but we will assign a proper TCP socket struct to it later on. This particular pointer will exist solely on the client, and in this example we will use it for receiving data. Unique pointer of TcpListener. The TcpListener is the wrapper for server-side fsocket that is just making certain things easier. And the last but not least, buffer size, that will tell us how many bytes at once do we want to send. Now, when we enter TcpListener, we can see it's working asynchronously, and we will have to keep that in mind when we will manage clients that have just connected. When we go a little further, we can see that it is also using fsocket underneath, and that is because fsockets are basic networking abstraction for Unreal. They can be used for UDP, TCP, both server and the client. Let's declare two functions that we will use. One for managing incoming connections on the server side, and the second one for connecting to the server on the client side. Here we can see that client connected is returning a boolean. This matter is very easy in fact. If we return true, the listener will not close the connection, otherwise connection shall be rejected. This function also gives us two arguments to work with. First one is the socket, that is the connection to the client. Now, someone of you may get confused, but this function is executed solely on the server. So don't assign socket from this function to the client socket that we made in the header file. This socket will be used for the server to client communication, in contrary to the socket in the header file that is for client to the server communication. The second argument is IP for endpoint. That means it is basically an IP address plus port, in this case of the client trying to connect to our server. Okay, let's get to the meat. We will start by creating server-side TCP logic. First, let's check if we are actually running on the server. So get net mode equal to dedicated server. Okay. Now let's create an endpoint, starting with an address. We provide IP for server to listen on. In this case, it's 0000 because we want to listen for all of the incoming connections. Let's provide IP address. The parse function will write this provided IP address into IP4 address struct. Now create an endpoint. Endpoint is basically an IP address plus port. And let's make unique, create our listener. We provide endpoint to the constructor, and TCP server should be already listening. Now the last thing we have to do is we have to bind our client connected function to the delegate. So server listener on connection accepted, bind view object, this TCP controller client connected. And the problem is it requires const. Okay, the last thing, let's just print something on the server console if we get the connection from the client. The server is already listening. We can connect to it from external sources, but now let's write the client. We start the same way as with the server by creating address and parsing the address into our struct server IP. But unlike with the server, we don't provide the static IP. We provide the IP to the server that we want to connect to. In this case, the IP that we'll take from the input in the widget. Let's create the endpoint. Now, we have to assign to our socket the TCP socket that we will take from the TCP socket builder. Let's give it a tag. And now, as reusable, will allow us to use the same connection, the same endpoint for multiple sockets. We've received buffer size. We provide our buffer size here. And this will tell the program how much data can it receive at once. And at last, as non-blocking, it will prevent the program from blocking while we perform operations on the socket. Now, let's create t-shirt pointer to the internet address. But before, we have to get our socket subsystem. It's platform dependent, but we don't have to worry about this because and will abstract it away for us. Platform. Socket subsystem. If we enter here, we can see that it's basically a set of macros, and if we are using Windows, it will get Windows. If we using Mac, it will get Mac, etc., etc. Now, get socket subsystem, create internet address, and set the IP. The IP is gonna be from our endpoint, address, value. The endpoint will convert for us the string that is our IP to the integer for connection, and address, set port, endpoint, port. And now all we need to do is go client socket, connect, and provide our internet address. Now we should be able to connect, so let's test it. Okay, we are now in the editor. We need to place a TCP controller actor on the level and integrate it with the widget. We have to add an event to the button. Now clicked. Let's get our text. Get text. For the sake of simplicity, we use get all actors of class and use TCP controller. Get, change it to reference, connect, this, and we should be good to go. Let's start it. Yes. Now let's press E. 127.0.0.1 connect, and as we can see, our client is connected. Let's send some data. First, we need to create an array of bytes that will transfer over TCP. Let's create a memory writer. First, array of bytes, and now memory writer and bytes. A memory writer is a struct that can serialize everything that overloads left shift operator, just a reminder, this is this operator, to hraqe struct. We will send a message from the server to the client. F string message, let's for example be it's really that great, guys. Great, check it out. Okay, memory writer message. Memory writer will automatically write everything into the bytes array. So here, this message will be serialized into bytes and will be written into this array. Finally, we can send our message to the client. So let's create first variable byte send. that will be explained in 1 minute. If socket send bytes get data bytes num bytes send, and now let's print a message in case something went wrong. Word able to send data. Now, the first argument is the pointer to the data that we want to send. Second one is a number of bytes, because the send method is taking the pointer to the data, not the actual TRI. That's why we use getData method. And the third one is the reference that will write to the variable that we provided how many bytes were already sent. So for example, if we want to send some really big data, this variable will be written, and then we can read how many bytes were sent already. Okay, all that's left now is to set up the client for receiving the data. First, we need to check if we are actually running a client. So let's again get that mode, then client. We will listen every tick for an incoming data, but first we have to ensure that socket is valid and we are actually connected. So TRI Wind8 bytes, and if client socket, well, not this, is valid, and now if client socket is actually connected, we have to check how much of the pending data awaits us and set bytes array size to that amount. So uint8 32 pending data if client socket has pending data and bytes set num pending data. Last thing is to read and deserialize the message. The rule is basically the same as with the sending data. We get the variable bytes read, is basically an equivalent to bytes sent. Let's check if we received some data. Bytes get the data. Depending how much data do we want to read and how much data we've read. Okay. Get our message. And now we have to use memory reader instead of memory writer. And while it might be confusing for some, but for the deserialization we use same left short shift operator as for serialization. The difference here is that instead of using memory writer, we use memory reader, to which we provide an array with bytes we got from the readsv method. Last, we print the message. String get word message true. Okay, now we can test if it actually works. We are in the editor, so let's start it. Now let's connect. And as we can see, you know that the industrial black metal is great. It's great for studying. It's really the great genre. What's happening here, basically, as a quick sum up, we connect to the server. The server receives the connection and accepts it. In the meantime, it sends the data with the message. Client start to listen for the data. It receives it, deserialize it, and print it. And that's how you send the data over the TCP socket. So like, subscribe, and we see each other in the next episodes. Bye.